morning, students. So in the previous class we have discussed about the potentiometers. That means in the resistive transducer, actually we have discussed about the potentiometer, strain gauges and other RTD, thermistor, so on. So we have completed the first resistive transducer, that is potentiometers. Now is the time to discuss strain gauges. So what is a strain gauge and what are the principle of strain gauge and what is the application? So before going to discuss about the principle and what you mean by strain gauge or application, first we should know what is meant by strain, and after that we will discuss about the strain gauge. So what is strain? Then a strain is nothing but the amount of deformation of a body due to an applied force. So if you take any body, say for example it is an elastic element or the flexible element, if you are applying some amount of force, that may be compressional force or elongation force, so the deformation for this body can happen. That is nothing but how much amount of deformation of an object or body due to applied force is nothing but strain. It is simply amount of deformation of an object or body due to an applied force. Or we can also define more specifically, you can say that strain is defined as fractional change in length, or it is also defined as change in length per unit length. So that is nothing but strain definition. For example, the length of this particular elastic element or a body is some 10 centimeters. So when you are applying some compressional force, this body may get some deformation, so it changes the length of this particular body, may reduce it to some 9.9 centimeters because of applying the force. That means the change in length is 0.1 centimeters. So 0.1 centimeter divided by 10 centimeters, that is nothing but strain, 0.1 by 10. Or if you are applying some elongation force, maybe assume that because of elongation force applied, the length of this particular element may increase to 10.1 centimeter, that is again maybe 10.2. So then the 0.2 is the change in length, that is deformation. So that deformation 0.2 divided by 10, that is nothing but strain. So change in length per unit length is nothing but strain. Generally the strain can be expressed by a symbol epsilon, So generally there are again two types of strain, that is called as longitudinal strain, lateral strain. That means when you are applying some amount of force in this direction, there is change in longitude, that is in the form of length, some dimensional change occurs. The similar way lateral, that is the cross sectional area, the diameter of this particular body also changes. That is called as lateral strain, change in diameter by unit diameter. Change in length per unit length is nothing but longitudinal strain, and that is called as lateral strain. So generally we will discuss about the most of the times strain, that is nothing but longitudinal strain. That also include actually the strain gauge is going to measure both strains. So the strain is nothing but delta L by L. So this strain can be positive or negative. Strain can be positive or negative. When you are applying some tensile force, what happens? The length of this particular body can increase 10 centimeters to some 10.2 centimeters. Then you can say that the change in length is plus 0.2 divided by 10. Or if you are applying the compressional force, the length is changed to from 10 centimeter to 9.8 or 9.9. That is 0.1 is changed, but that is negative. That means for tensile force, strain is positive. For compressional force, strain is negative. The tensile is also nothing but elongation force. Okay. Now, just now I explained what is that. So here this is called as a actual body. When you are applying some tensile force like this, so the length is increased to from L to L plus delta L, and the diameter is also changing to some delta D also. Okay. So actually the strain is not having units. Why? Because delta L by L, delta L change in length is also in the form of millimeter or centimeter, and L is also millimeter centimeter. So millimeter will be cancelled, or centimeter will be cancelled. So that the strain is not having units. So you can say that it is a dimensionless quantity. Strain is a dimensionless quantity. But generally the strain is very minute. If you are having some 1 meter body, by applying some force, compression or elongation force, the change in length may be in the form of millimeter, 0.1, 0.01 mm sometimes in the industries. So that 0.01 divided by meter, that it comes in the form of microns in terms of 10 power minus 6. That's why sometimes we can specify in terms of microns, micrometers. So micro strain, that can be as 10 power minus 6 into, so that like that also we can say epsilon into 10 power minus 6. So now that is about the strain. So what is strain gauge? Strain gauge is a device used to measure deformation of an object or strain of an object. That means when you are applying some force, there is some deformation exists in an object. So that deformation or strain can be measured by a device called strain gauge. So it is an example of passive transducer that converts the mechanical displacement into a change of resistance. Why I am calling it as displacement? When you are applying some displacement on an object, that object may create some force. That means actually the displacement is converted to force, that force is converted into strain. So that's why these strain gauges are used for measurement of force, displacement, pressures, etc. Okay, so that's why the strain gauge is an example of passive transducer. What is passive transducer? So it can convert this mechanical displacement or force into electrical signal with the use of some external supply. So that's why strain gauge is an example of passive transducer that converts a mechanical quantity or mechanical displacement into change of resistance. Okay, so that change in resistance can be converted into electrical signal, that is maybe voltage, by using some bridge circuit and external voltage that we are going to see in this class, in this subject, in this topic. So that's why it is called a passive transducer. So first we will see what is the strain gauge main principle. If a metal conductor is strained, take this as metal. If this metal conductor is strained by applying some stretch or compressing, stretch force or compression force, its resistance change on account of its change in length and diameter of conductor. Just now I explained, as you are applying the force, the length may increase and diameter may decrease. Or if you are applying the compression force, the length may decrease, diameter may increase. So if the metal conductor is stretched or compressed, the resistance of this metal conductor changes on account of changes in both length as well as diameter, that is longitudinal and lateral dimensions. So actually there is a video, but this video is not playing in the PDF. Just I will discuss, I will play that video in the normal Zoom class. So also there is change in value of resistivity of the conductor when it is strained, and this property is called as piezoresistive effect. So when you are applying the elongation force, the length of this metal conductor increases as well as diameter changes. So as we know that R equal to rho L by A, the resistance of a metal conductor is depending upon the resistivity, length of the conductor and cross section area of the conductor. As the length increases, because of R equal to rho L by A, as the length increases, resistance also increases. And as the diameter decreases, which is inversely proportional, for R is equal to rho L by A, inversely proportional. So the diameter will in turn changes the cross sectional area. So that also changes the resistance. But for some cases, there is also change in value of resistivity of the conductor. So when you are applying the force, there is some charged particles are there. So because of movement of charged particles, the conductivity, in turn resistivity also changes. So due to this change in resistivity, the resistance also changes. This property of change in resistance due to change in resistivity is called piezoresistive effect. Therefore, resistance strain gauges are also called as piezoresistive gauges. Listen carefully. When a metal conductor is stretched or compressed, the resistance of the metal conductor changes on account of length and diameter, and also some special cases there is change in value of resistance due to change in resistivity. So this special property, change in resistance due to change in resistivity, is called as piezoresistive effect. Piezoresistive effect. So generally the strain gauges are used for measurement of strain and associated stress in some experimental stress analysis. So in the industries or in, especially for civil engineers also, they are going to test some stress analysis when they are going to construct a bridges. They are going to analyze the beam stress, up to what strength or what stress it can withstand. So they are going to apply some amount of forces and they are observing the deformation or strain. So otherwise what happens, as the load to the bridge increases, what happens, if the load is more than the required, more than the normal level, what happens, the deformation may be more and there is a chance of collapse in the bridges. And also in industries, especially mechanical industries or manufacturing industries, they are going to design a particular maybe iron table. There also we want to test the stress analysis. We want to go for stress analysis. So they are going to put some objects on the table and they are going to analyze the strain, what is the deformation. So that's why if you are going to purchase any equipment, any mechanical device, they are giving that the maximum weight you can put on the particular table is some 10 kgs or 20 kgs. So that can be known by providing some stress analysis. This stress analysis can be done by using strain gauges only. And also secondly, these strain gauges are used as a secondary transducer along with some transducers called load cells, especially in weighing bridges. If you observe any in highway, we are having some weighing machines, weigh bridges. There they are going to measure the weight of the trucks. The trucks or lorry which carries some cement or some sand, then we require to measure what is the weight of the sand. So there we are going to measure that weight of trucks by using load cells. The load cells, the strain gauges are using as secondary transducers. Already I have discussed about the primary and secondary transducer in classification of sensors. So generally the primary transducer convert the actual physical quantity into some secondary variable, and that can be converted to electrical signal by using secondary transducer. So the load cells convert the weight into some strain. When you are applying, for example, this is the load cell platform. When a lorry is there or weight is there, what happens, this platform will become like this, the bending force will be there. So because of this, some what you call as dimensional change, deformation will occur. So this amount of deformation is depending upon the amount of force. So that strain can be observed or measured by the strain gauges. That's why for weight measurement, the strain gauges are used as secondary transducers along with load cells. Or if you observe your any general stores, we are having electronic weighing machines. So we are observing some platform. That under that we are having some load cell, and then we are having the strain gauges. And also for different torque meters, diaphragm type, pressure gauges, temperature sensors, some accelerometer, etc. These strain gauges are acting as secondary transducers for measurement of different physical quantities. Now we will see the theory of strain gauges. The change in value of resistance by straining the gauge may be partly explained by normal dimensional behavior of elastic material. Just now whatever I explained, that is the same. The change in value of resistance by straining the gauge may be explained by the normal dimensional behavior of the elastic material. Now we will see, as per our equation R equal to rho L by A. For example, this is a metal conductor. So whenever it is not strained, you can say that unstrained, no strain, no force is applied. Now it is called as unstrained material. So at this moment, at unstrained moment, this is having some amount of resistance. Maybe assume that some 100 ohms. And when you are applying some amount of compressional force, there is change in length, that is decrease in length and increase in diameter, and maybe also change in resistivity. Due to that, some resistance may be changed. That resistance is due to that change in resistance. Now the resistance of this strained conductor becomes some 110 ohms. For example, not exactly, maybe change to 100 ohms to 110. That means this change in resistance 10 ohms. That is a delta R atom. That is delta R depending upon the strain. So how or in what way this change in resistance depending upon the strain, we are going to see by using some mathematical calculations and some assumptions. Okay. So if a strip of elastic material is subjected to tension, that is elongation force, or in other words positively strained, its longitudinal dimension will increase, that is length will increase, and there will be a reduction in lateral dimensions, that is diameter will increase. So when a gauge, you can say that this is a gauge or elastic material. I am assuming here as elastic material. So when a gauge is subjected to positive strain, its length increases and also while its area of cross section decreases. Since we know that by using the equation R equal to rho L by A, the resistance of conductor is proportional to its length and inversely proportional to cross sectional area. Therefore, the resistance of the gauge increases with positive strain. That means when you are applying the elongation, the length will increase, diameter will decreases because of the equation R equal. So the resistance of the gauge increases with positive strain. You can also say that the resistance of the gauge decreases with negative strain. That means when you are applying a elongation force or tensile force, the resistance can be increased. When you are applying a compressional force, the resistance of the gauge may be decreases. So the change in value of resistance of the strained conductor is more than the change in resistance due to length or due to physical dimensions, that is due to change in length and area. For example, if you are having a conductor, I am applying some elongation force. So the resistance of this conductor is changed from 10 ohms, for example. Simply assume that 10 ohms to some 11 ohms. Actually the change, how much was the change in resistance? 1 ohm. But actually the change in resistance due to change in length and area is maybe only 0.4 or 0.5 ohms. The remaining 0.4 ohms, that is due to change in resistivity. The extra change in value of resistance is attributed to a change in value of resistivity of a conductor when it's strained. So this property is known as piezoresistive effect. So that we can conclude that the resistance of any conductor is changing due to change in length, due to change in lateral, that is the diameter, and also there is extra change in resistance due to resistivity. So that is actually property of strain gauge. So by measuring the change in resistance, we can estimate what is the amount of strain occurred. So for some materials, such as especially for strain gauge semiconductors, the change in resistance is more on account of change in resistivity. So that we are going to discuss in actually different types of strain gauges. I would like to discuss about different types of strain gauges later. There we will see everything. So actually how this change in resistance of a metal conductor is depending on the change in physical quantities such as length, area. So that can be explained by some elastic material or just some normal dimensional behavior of the elastic material. So with some equations, so there are some different derivation of equations we are going to see in the next class. So that is actually we are going to derive an expression called gauge factor So actually the gauge factor is nothing but sensitivity. As we know that sensitivity is nothing but ratio of change in output to the change in input. So for strain gauges, the output change is nothing but change in resistance. Input quant is strain, that is change in length per unit length. So how actually that is depending upon these quantities, and what is the definition of gauge factor and what is the expression for gauge factor, that we are going to discuss in the next class.